All right. What is a discriminant and how is it used? A discriminant is used specifically in a quadratic formula, or a quadratic equation, and it's derived from the quadratic formula. So a quadratic equation would be something like this: ax squared plus bx plus c equals 0, where a, b, and c are some real number, or imaginary for that matter. So what we would do is to find the discriminant, we need the quadratic formula because that's where it's derived from. The quadratic formula, hopefully you already know it, but it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant literally is that b squared minus 4ac underneath the radical, because this radical discriminates on, it tells us what's going to happen to this thing. Because the square root of a negative is imaginary. The square root of a perfect square is a natural number. And so you can kind of get some information without using the whole quadratic just from this b squared minus 4ac. You can tell whether it's factorable or not. Or I use factorable loosely. It could be it's easily factorable this way. You can determine that. So here's what we have. So the discriminant is b squared minus 4ac. And you always want to keep that radical in mind. What if you get b squared minus 4ac being something, what's the radical going to do to it? That's going to tell you what your roots look like. So b squared minus 4ac. So let me give you just an example. So let's say we had 2x squared plus 3x plus 4, because I have no imagination. And so we know the quadratic term a is 2, the linear term b is 3, and the constant term c is 4. And so if you apply b squared minus 4ac to this, you get b squared, you'd have 3 squared, which is 9, minus 4 times 2 times 4. And so you'd end up with 9 minus 4 times 2 is 8, and then 8 times 4, just keeping our order of operation going. So you'd have 9 minus 32, and 9 minus 32 is going to be a negative number. And honestly, you can almost stop there. It's going to be negative. So that tells me I'm going to have an I involved. And so we got, what do we have? Negative 23. So negative 23, you think back and you plug that back in to this radical here, and it's going to be plus or minus. We're going to have two complex numbers as roots. What's a complex number? A complex number is a plus bi. Anything where these are real, a and b are real numbers, and I is your imaginary part. So it's going to be two complex conjugates, actually. So that brings us to 3 or 4 different levels for this that are good to have memorized. Other than, I've never memorized them other than the fact that I've done them forever. So it's somewhat, to me it's somewhat meaningless other than to get you through a college algebra course. But I'm sure somewhere somebody uses it, and it's important there. But here you go. Now at least you know what the term means. So b squared minus 4ac is greater than 0 is, if it's greater than 0, that means it's a positive number, like positive 1, positive 2, positive 100, positive 1,000, whatever. If you got two situations. The first situation is if it's a perfect square. And what do I mean by perfect square? Well, I mean like 25 or 16 or 9 or 4 or 1. If it's a perfect square, you're going to have two rational roots. Or you might think of the problem as being, you're going to come up with numbers that you're kind of comfortable with. Like maybe you're going to have 1/2 and 3 or something like that. You're going to have two nice numbers. Two natural numbers possibly, or two rational numbers at least. So you're not going to end up in the irrational realm at all. If it's not a perfect square, so that's the situation two, the second situation, not PS, perfect square. Then you're going to have two real roots. Two real number roots. So in this case, it could be complex. Well, it will be complex. It'll be two complex roots, or not complex, sorry, two irrational roots. So you could even go a little further here. So if it's a perfect square, it's two rational roots. If it's not a perfect square, it's two irrational roots. And together, if you have a positive number, for sure, back here to the top, let me stop here, we know immediately that we're going to have two real answers, or two real roots, we call them. So for sure you're going to have that, but if you want to break it down further, you could have two perfect square. A perfect square would give you two rational roots, and not a perfect square means you're going to have irrational roots. So maybe you got 7 for b squared minus 4ac. Well, that's going to be two irrational roots, and I'll take that real out of there. I apologize. So, like I say, I don't really have this memorized. I'm just using logic to figure it out. So you're going to make a few mistakes. So b squared minus 4ac, what happens if it is 0? Well, think about it. If it is 0, this entire term is 0. This whole square root is 0. The plus or minus now is 0. So now you got b plus or minus 0 over 2a. Well, plus or minus 0, this is gone. And so you have b over 2a. So you only have one answer. So if b squared minus 4ac, we call that is equal to 0, we call that one double root. One double root. Or, you have one answer. Okay, and that's it. It's 0, it zeroes out. It's gone. Now, if b squared minus 4ac, we already did this example, is less than 0, or a negative number, you have two complex roots. And if you know what a conjugate is, two complex conjugates. Conjugates are like a complex conjugate. Let's say you had 2 plus I as a complex root. Its conjugate, you really have also 2 minus I. Those are conjugates. 2 plus I, 2 minus I. So there you have it. Honestly, I think that's about all you need to know about the discriminant. I'm sure there's more, and I'm sure I butchered this bad enough that if other math people watch it, they're probably horrified. But honestly, I think that's all there is to it. And good luck, and see you next time.